Hello and welcome to Let's Code Physics. Happy Friday. We are going to continue developing our FTL beam optimizer. We've successfully created a graphical user environment in which somebody can create an FTL ship layout using these room buttons over here to then click and drag rooms into various arrangements. We've also got the options to delete a room if you need to. We've got the different beams that you can select, and we've got different options for running the code. You can maximize the number of rooms, maximize the number of tiles, make sure to hit a specified room, and maximize damage with the whole beam. And so what we need to do now is we need to actually write the optimizer, right? This is a wonderful little, graphical creation, but it's not actually doing the optimization yet. You click on the green button here, and it doesn't do anything. That's because we need to actually write the optimizer. So I've set up a shell for the optimizer program here, and basically this is going to run when we This is going to run when we click on that green button. When we click on the click to run optimizer, it'll go into this subroutine here and will then run the optimizer. What I've set up here is what's called pseudo code. This is where you have an idea of what the code needs to do. You know where there needs to be a loop. You know where there needs to be an if-then statement, but you're not writing it in strictly code yet. You're writing it in what reminds you of you need to write the code later. That's why it's called pseudo code. Really important in the code planning process. So what I want to do over the next 20 to 30 minutes is actually write this code. I'm only going to do it for one scenario. I'll do it for the basic scenario of maximizing the number of rooms hit. And then off camera, I'll make some additions to get the other three scenarios just so that I don't bog you down with all the details there. And then I'll just show you them in action in the next episode. So what I'm hoping to do is in the next episode, get a game of FTL started, hopefully get one or two beam weapons, and then actually use this along with the game to show you just how useful it can be. I do want to get this series wrapped up by next week because the following week I want to start another fun series that will be somewhat timely for coming events. Let's just say that. The first thing that I need to do is establish where the optimizer is going to run. There's no real point in having it run everywhere all over the grid. It should only run within the bounds of the ship. So what we're going to do first is we're going to determine the bounds for the locations to consider. So what we're going to do is we're going to create some variables called left edge, right edge, top edge, and bottom edge. And they're all going to initially be this grid runs from -10 to 10, right? Make grid, yeah. The grid runs from -10 to 10 in both directions. So we'll just have it start out that way. Right edge, and then we'll have bottom edge and top edge. Bottom edge and top edge. Cool. And now what I want to do is I want to look into each of the, I want to look at each of the rooms, and I want to modify those values based on where those are. So actually it occurs to me I need to flip these actually because I want the left edge to start out at the right and move inward, and I want the right edge to start out at the left and move inward. So it's going to start at the opposite of what you want, right? So when you want to maximize something, you start with as small a value as possible. When you want to minimize something, you start out with as large a value as possible. Okay. And so we've got room list coming into this function, so I can use that. So what I'm going to do is I'm going to loop over the room, over the number of rooms. We're going to start out with I equals 1. Next, let's even call this thing I room just so we can keep track of what it is it's counting. We'll say while I room is less than or equal to number of rooms. It should be legal, right? Am I using that variable? Okay, I do need to put it in as a global. Yes, in rooms is fine. So I just need a global variable in rooms. I could technically use length of the room list, but I find this is a little bit easier, and it makes a little bit more intuitive sense to me. While I room is less than or equal to the number of rooms, now we need to determine the left and right edge for that room. So I'm going to copy, or we've already done that, because we've already in the snapping area where we are moving the rooms around, We've already, actually it's in the drop, isn't it? And so what we can do is use these and get the right edge and left edge for each of the rooms. Cool. Copy. That is frame list. Yeah, I don't need to worry about the frames anymore. And let's go, oops. I missed where I wanted to go. There it is. So what I can do is I can paste that in here just so I don't have to recreate all of the math and geography and everything. And let's indent everybody properly before we start fixing anything. So we're going to edit, format dendent region. I'm pretty sure that's de-indent, but we'll call it dendent, whatever. And I guess that needs to come, nope. These are actually off by one. Not sure why that is. There we go. So it should be 4 in, right? 1, 2, 3, or 1, 2, 3, 4. I'm not sure that it matters all that much as long as it's consistent, but I'm not going to get into I'm not going to go through all of this programming, just get into an indentation battle. Okay, cool. So I don't want to call these right edge anymore. So actually, all right, I've got the same names over here. So let's actually change these. Instead of edge, let's call them bound. There we go. It's easier to change these once rather than changing all the edges, 100 times down below. Top bound. Okay. Cool. And so what I can do now is I can use for example, if I'm looking for the right edge, right? Oh, actually, I don't have to do that inside the if command, right? Because I'm getting the right edge and the top edge. What I can do now is I can say, okay, so the right bound is going to be the maximum. So the max function takes any number of arguments and returns the maximum of them, max between right bound and right edge. And it'll do that every time. So every time it'll check whether the next room is to the right of the previous room, or whether its edge is to the right of the previous room. And then I can do the same thing with the top bound. So top bound can equal max of top bound and top edge. Cool. Now I haven't done anything with the left edge yet, so I need to also create a way to calculate the left edge, for example. Oh, and actually, I don't need to be updating the room list positions anymore, do I? Nope. That's in the other code because we're not moving them here. We're just examining where they are. Cool. So we've got right edge, and so left edge needs to be, let's see, so this thing's size in the x direction is 1. So that means its left edge is going to be its right edge minus 1, right? So if it is 1 unit wide, whatever the right edge is, the left edge is going to be 1 minus that. And then oh, excuse me, that's greater than 1, so that should actually be minus 2, excuse me, because that means it's 2 wide. This one means it's 1 wide. I got my less than or greater than flipped around. So this means left edge is going to be right edge plus 2, or excuse me, minus 1. I flipped the wrong thing. There we go. So we're either taking it 2 to the left or we're taking it 1 to the left. Cool. And then I can do the same thing with the top and bottom here. So if its size is 2, then that means that bottom edge is going to be top edge minus 2. Or down here, the size in the y direction, the height is 1. And I can say that bottom edge equals top edge minus 1. All right, so I got minus 2, minus 1, minus 2, minus 1, greater, less, greater, less. Okay, cool. And then within each round of the loop, it's going to evaluate the right bound to see whether it needs to be increased, or the top bound to see whether it needs to be increased. Oh, and then I need to do the same thing with the left and bottom bounds. May as well make this symmetric. Left bound equals max. Actually, that needs to be a min, doesn't it? Of left bound and left edge. There we go. And then same thing here. The bottom bound needs to be the min of the bottom bound and bottom edge. So for edge, bottomage, bottomed G. So many ways you could read that. So whenever it's right or top, I want the maximum because I want those to be increasing numbers. Whenever it's left or bottom, I want the minimum because I want those to be decreasing numbers. Okay, cool. So I've successfully determined the bounds for the locations. Awesome. So now that I'm done with that piece of the pseudocode, I'm going to delete it. What I can do next is, so as I'm looping over the different possible beginning points and orientations of the beam, I want to be able to evaluate which one gives me the best score, right? In this case, score is going to be the number of rooms, but you know, later on it'll be, you know, the maximum amount of damage, maximum amount of tiles, or something like that. So we're going to say maximum amount of, so we're going to start with max score equals 0. We're going to evaluate whether the score that we get is bigger than 0, and on, again, using the max function. Okay, so the next thing I need to do is loop over all the possible starting locations, right? So I want to be able to move within this square that's created by the ship and start my beam anywhere in there. So we're going to start with, let's call the position, the initial position of the beam X0 beam, right? Let's call it X0 beam. So that is the initial position for the X of the beam. Yeah, I like that. X0 beam is going to be the left bound. Y0 of the beam is going to be the bottom bound. Cool. And then we're going to say, actually, I need to go ahead and start a loop here. So while X0 beam is less than or equal to the right bound, there we go. Now I can set the Y0 beam because as I go around the X's, as I try different X values, I need to reset the Y value so they're not just going in a diagonal line. I'm trying every possible location on the grid. Y0 beam equals bottom bound, and we're going to say while Y0 beam is less than or equal to top bound. So I'm going from left to right and bottom to top. And I'm going to go ahead and help myself down here by adding in a Y0 beam equals Y0 beam plus dy. And I'm going to do the same thing here. X0 beam plus dx. Actually, I need those to come in, don't I? Because this while loop starts at column 8, and I need a colon there, so this needs to come in one more. This needs to come in one more. There we go. So that way this is lined, that way this X0 is lined up with the beginning of this while loop, and this Y0 here is lined up with the beginning of this while loop. Cool. Okay, I'm now looping over the calculations. I need to give it a dx and a dy. So let's do that. Let's say dx equals, let's start with 0.1 and dy. There's no real reason to have them be different, but I'm just giving the different names so that way I don't wonder why I've got an x in the y line. You know, just good practice. Okay, cool. So now my code is ready to start searching at each location in the grid. So let's see. So the next thing I need to do is, so I've got the starting point. The next thing I need to do is try different angles for the beam. So I need to loop over the angles. So I need to have a theta equals 0. So we'll start out at theta equals 0. Oh, actually, what range does the what range do angles go over in VPython? Does it go 0 to 2 pi or does it go minus pi to pi? I don't know. Although it shouldn't matter, should it? Because the sine and cosine function can take it. Okay. Still, it might be beneficial to look at. That looks like 0 to 2 pi. Okay, we'll call that 0 to 2 pi. So we'll go theta equals 0, and we'll say while theta is less than or equal to, it won't. A while loop doesn't run very long if you say while it equals something. While theta is less than or equal to 2 times pi, and I want to say that Python knows what pi is, but just in case it doesn't, we'll go 3.14159. There's usually plenty of decimal places. And then down here, I need to have a theta equals theta plus d theta. And you know what? No reason to make that any different than the others. D theta. Let's make that equal to dx as well. It's different units, but, you know, 0.1. It says 0.1 out of pi. Let's make that pi out of 100. That way it's 0.03 something something. Right. Okay. Cool. So I'm looping over the angles. You know what? I actually need to leave some comments here for myself so I remember what this is doing. Loop over position, starting positions. This one will say loop over angles. Cool. So I've got my while theta equals theta plus d theta. So you notice I'm replacing my pseudocode with code. It's also getting longer along the way, which it should. Okay, cool. So one thing I need to do is I need to keep track of the rooms that have been hit, right? So if a room has been hit, it needs to only count toward the score once, right? So what we're going to do is we're going to create a list called, let's call it hit rooms. I almost called it, I almost flipped those. Not going to happen. This is a PG channel. Hit rooms is equal to 3. Cool. Or is equal to 3. Is equal to 0. Is equal to a list with 0. Just looking up at the 3 there on the pie. So we're going to say the number of hit rooms, or excuse me, the list of hit rooms is just set to 0. Cool. And now what I need to do is I need to crawl along the beam. I need to crawl along various positions along the beam. So I need to say that x beam is equal to x beam 0. And this time I am going to connect the x and the y because I'm only moving along the line there. I'm not looping over all the possible locations. I'm looping over all the locations along the beam. So we'll initialize x beam 0 and y beam to be y beam 0. There we go. Loop over coordinates along the beam. I'll tidy up the grammar on the comments later, I think. Okay, and so what I can do now is I can say while x beam is less than or equal to, okay, so let's see here. What is the condition I'm going over now? What I'm doing is I'm going over the beam, so this thing needs to stop when it's gone the length of the beam, right? So let's do a little calculation here. Let's say that, do I want to call it length? You know, I need to be thinking of this as a right triangle, so let's call it hypotenuse. Hypotenuse is equal to, so as I go along the beam, I'm thinking about changing the x and changing the y, then change the x, change the y, so I'm getting a straight line, or a diagonal line. All lines are straight. I'm getting a diagonal line, so I can think about it in terms of the rise and the run, and or the opposite side and the adjacent side and the angle and the hypotenuse. So hypotenuse is going to be square root of x beam squared plus y beam squared. So while the hypotenuse is less than or equal to, I already have beam length being passed as an argument to this function. Cool. So I've got while the hypotenuse is less than or equal to the beam length. And what I'll need to do is I'll need to evaluate the hypotenuse at the end of every step in the loop. So if I go down this way, I think I indented that theta too many times. Because that theta needs to be there. Oh, you know what? I did not, I didn't indent my theta stuff properly. Oops. Oops. So we're going to go here. We're going to add an indentation, because this all needs to be inside the y0. So this gets indented, this gets indented, this gets indented, this gets indented, this gets indented. So this was right. I had to fix all the others. And so what I'll do at the end is I'll recalculate the hypotenuse, right? And I also need to increment x beam and y beam. So I'll say x beam equals x beam plus dx. Y beam equals y beam plus dx. So think of that as the location where we are evaluating the beam, right? So x beam, y beam are the coordinates along the beam, right? Actually, I need to indent those again. we go. So it's going to evaluate this at the end of that loop. It's going to evaluate this at the end of the loop so it knows when it's gone the length of the beam. Let's see. Plus dy. Oh, that's not necessarily going to work, is it? No. I need to have y beam be equal to, I need to do y equals mx plus b. So I need to do that the y beam is equal to y beam 0 plus x beam minus, wow, x beam minus x beam 0. So maybe I should draw a little diagram here to help myself and the viewer. Okay, so we've got the beam going along this way, right? So we've got it set up to where we've got our angle theta in here. And so we want to go up to a certain location here. And what I'm suggesting we do is bring the, oh gosh, if it's a very vertical beam though, I don't want to be incrementing the x. I want to be incrementing the hypotenuse, don't I? So what I need to do, I'm glad I drew this now. What I need to do is increment the hypotenuse along here. So I want hypotenuse to go from 0 to the beam length. BL, that's me. I want to go from 0 to the, I want hypotenuse to go from 0 to the beam length. And so what I need to do is then I need to do my trig here and have the x be the hypotenuse times cosine of theta, and I want this y to be hypotenuse times sine of theta. There we go. Okay, so actually let me change that a little bit. There we go. Oh, and that won't work anyway because that's the coordinates, that's not the length. Oops. Okay, so let's start out at hype equal to dx, for example, so there's no point in having a hypotenuse of 0. So hypotenuse less than or equal to beam length. So rather than incrementing these, we will come back to these in just a second. I want to increment hypotenuse. So I want to say hypotenuse equals hypotenuse plus dx. Sure, why not? Just keep it the same. Yeah, and it'll stop when the hypotenuse reaches the beam length. So we're going to say x beam equals its initial position, right? Because this coordinate right here is already at x beam 0 and y beam 0. So I want it to be x beam 0 plus this amount. I want it to be y beam 0 plus this amount. Okay, cool. This is coming together nicely. So we're going to say hypotenuse times cosine. X gets the cosine, yes. Cosine theta. And then I want to say hypotenuse times sine of theta. Cool, cool, cool. So we are starting these out here. Oh, so actually I don't need to start them there. They're going to start at x beam 0 and y beam 0 every time. Right. I do want those to start there, and then they'll move forward by this amount initially. Oh, actually, yeah, I do want this to be 0. Excuse me. And then I'll increase that there. Okay, cool. Okay. So, finally got it figured out. So this is going to start x and y at x beam 0, y beam 0, and then it's going to increase, it's going to move them to this coordinate each time. I think I'm going to need to put in an animation to confirm that what I think is happening is actually happening. So the next thing I need to do is I need to loop over the room list and evaluate whether the beam is in that room. So let's start a loop over the room list. So we're going to start I room equals 1 again. So we're going to start with that again. So while I room is less than or equal to the number of rooms, and in keeping with my new tradition, I'm going to go ahead and put in an I room equals I room plus 1. So I do not forget it. And now we evaluate whether that that x beam y beam is in a room, right? So let's see here. So we've already got this business about getting the left edge and right edge. So let's go ahead and steal those from over here. Copy. While I room less than number of rooms. Go paste. And then we will take these folks and indent them. I want to indent them. Oh yeah, if you do control bracket, it does an indentation. There we go, cool. So now I've got a way to get left edge and right edge. Awesome. Although, again, I indented those one too many times. Control left bracket. There we go, that's better. I'm not sure why that happened there. Okay, there we go. So we've got, well, iRoom is less than the number of rooms. We are already incrementing over iRooms. So now we want to look at, let's see here. Well, iRoom is less than the number of rooms. If xbeam, so let's see. So I want to find out, so let's go back to the diagram. So let's suppose we're evaluating this point along the beam. We want to evaluate whether it is located inside a room here, right? Pretend that's a square. Just pretend with me here. So this thing is going to have a left edge, and it's going to have a right edge, and it's going to have a top edge, and it's going to have a bottom edge. So I need to check 4 things. I need to check whether this point is greater than left edge, whether it's less than right edge, whether it's greater than bottom edge, and whether it's less than top edge. Whew! So if xbeam is less than the right edge, and xbeam is greater than left edge, and xbeam is less than top edge, and xbeam is greater than bottom edge. Right? Less than the right, greater than the left, less than the top, greater than the bottom. Cool, there we go. So now we check to see whether the room has been hit, right? Because we also need to check whether whether we've already registered that room as being hit. We call that hit rooms. So we say I hit rooms is equal to 1. And I'll say while IHR is less than or equal to length of IHR minus 1. And now we're going to check whether this room has been hit. So what I need to do is I need to check whether this is a new hit, right? So let's default it to new hit equals true. So this is new hit equals is this a new, actually, let's change it to hit before equals false. So hit before equals was this room hit before. So while IHR is less than or equal to length of, while that, if the, let's see, we're checking hit rooms of I is equal to iRoom, meaning if this item, this iRoom value is already included in there, then we say hit before equals true. So we're going to switch it from false to true. And regardless of that, we're going to increment IHR. You thought I was going to forget that, didn't you? IHR equals IHR plus 1. So now we want to say, so now if not hit before, so if it has not been hit before, then you add 1 to the score. Score equals score plus 1. I should probably initialize that score value. So we are going over x0, y0, and theta, right? Score equals 0. This will be reset the score. We will not settle the score, but we will reset it. Cool. And yeah, so here we're looping over the coordinates along the beam. So we're doing a single run along the beam. Cool. So if room or tile is hit and wasn't before, then we update score. And we need to add the room to the list of rooms that have been hit. So if the beam coordinate is inside the room, we are checking whether it was hit before. We're coming out with true. We have a possibility to come out with true. Score equals score plus 1, and I need to add it to the hit room list. So hit rooms dot append iRoom. Cool. So if the, let's take our pseudo code here. So if the room or the tile is hit and it wasn't hit before, then we update the score and we add the room to the list of rooms that have been hit. Yes, as we're doing here. Let's put that up here to remind me that that's what this block is doing. Okay, cool. And finally, if we've exceeded the maximum score, so all of this is occurring, the score is being evaluated and it's being added to under the while theta loop. So after I update theta, right, actually before I update theta, right, when I'm done with the theta loop, I need to store the location and the angle. So if our score is greater than max score, so this is now where we're going to check this, then we have a few things to do. We need to change the max score first of all to update it. And we need to save the starting coordinates. So we need to save x, let's call it best x equals x beam 0. We'll call it best y equals y beam 0. And best theta equals theta. Cool. And otherwise, it'll just leave it alone. It won't change anything that we had before. And let's put that over here. So if we've exceeded the maximum score, then we store the location and the angle. Now, one thing that I'll look at off camera is whether I can get the computer to report multiple angles, because it's possible for multiple angles to produce the same score. I don't know whether that might be it might be worthwhile if you get a beam going this way, a beam going this way, and you'd rather have this one for some reason because it hits the weapons or something. Okay, cool. And then so technically this is done. It is going through all the loops. I'm gonna cut in just a second and do a proofread, but I also need to create a curve with a winning orientation, so that people know, so that the user knows what the end result is. I'm going to come out here, and we are going to create a curve. Let's call it winner. Winner. I wind. That makes me a winder. Or you might need to have your winders washed. Let's see, winner needs to be a curve with, all right, now let's see here. We want to have it start out at x best, or best x, excuse me, best x, position equals best x comma best y comma 0. And we want it to end at those same locations plus whatever the angle is. So plus, we want to have beam length times cosine of best theta. And then we want to do the same thing with the y. Oops. We want to do the same thing with the y. We want the best y to have added to it beam length plus sine of best theta. And then, of course, it needs to end with 0. That'll end the... It will not end the position. Oh, I've got an extra parenthesis there. Okay. So now I close up that. Let's say color equals, let's make it color dot red. I think that's the color that you're, does it show up in red or show up in yellow? I'll check and find out. And we'll say thickness equals, let's make it 0.1. How thick are the grid lines? Grid lines are, it doesn't specify. So we'll say the winner equals this thing. Let's try thickness 0.1. So I'm going to go proofread this. I'm going to do a trial run, and I will be back in just a second. So I found some things I needed to proofread. Like I needed to turn some I's into I rooms and things like that. I also made a mistake where I had these Y's as X's and they should have been Y's. Oops. I also found I needed to remove the rounding commands on the determining the top edge and left edge, etc., because they're already rounded, right? We're not snapping them into place anymore, so I don't have to worry about that anymore. And it seems to be working now. So I've got the code running. So I've got this nice setup, so that way as the beam cuts across, it'll hopefully hit all 3 rooms. Let's try it out with the glaive beam, which is a moderate length beam in the game. And what I've also added in is the animation of a line that's going to show you where it's currently scanning, and then at the end that line will turn red. So initially it's green. Let me double check that. Yeah, so initially the line is green, and then it's going to become red at the end, and it'll be updated to the best combination. So let's see what happens here. I will probably fast forward through this part, and then off camera I'll work on speeding it up after the episode. Let's click to run Optimizer. shoot, do I have any rates in here? Oh, shoot. Speed that. So it turns out to actually take a lot less time than I thought. So I forgot to take out the rate commands and without all the print statements. It actually runs very quickly. So let's take a look. So let's do the same room the same ship that I've been trying to slice across. They've probably, you know, jumped by now. Let's give it the glaive beam and we'll run the optimizer. So it also prints every time you get a new max score. I'll probably turn that into something a little more user-friendly. And it says, here's your winning beam. Long live the Federation. Because it's the Federation who are the good guys, Kyle. The rebels are the bad guys. Right? Okay. And so basically it takes whichever one strikes first there. So what I can do now is I can make the room, I can make a ship with a little bit more interesting arrangement. So like, for example, let's actually do a real one. Let's do FTL Mantis ship. Let's see, take me to images. I don't want the one that you get. I want the Mantis enemy ship. Oh, this one ought to be fun. Let's try doing this one. Yes, here we go. And so I need a 2x2, and then I need a long one. Then I need a few more long ones. Okay. Then I need to do the same thing on the other side. And then I need two. Still having a little issue with snapping. There we go. And then I need two on the wings there. Does that match that ship? Yes, that does match that ship. Let's say we're striking it with the, let's go with the glaive beam. And let's where's my display? Here we go. Let's click to run the optimizer. So we can hit at least 3 rooms. We can hit at least 4 rooms. Here is your winning beam. Long live the Federation. So apparently the best beam for this cuts across this way. It gets you 1, 2, 3, 4 rooms. So there you have it. There is our FTL optimizer in action. It doesn't take all that long to use now that it's finally set up. So off camera, I'm going to set up the various different options for tiles, hull beam damage, specifying a room, etc. And that will change the way the scoring works, but it'll basically run through the same pattern. So thank you so much for watching. I will see you next time. Bye-bye.